this chapter, we're going to be looking at puzzles and games. And we'll be doing that as a means of looking at logical reasoning.
So now, in this lesson, we're going to talk about essentially what's going to boil down to logical reasoning. Okay, it used to be taught in the curriculum. It used to be in there in grade 10, 11, 12. There would be a section there where we would talk specifically about logical reasoning and help people kind of give them a framework within which to work here. That's kind of been pulled out here, but it's been replaced in this particular course with a quick little unit here. And it's not very much, but just a quick discussion of puzzles and games. Now, the reason why we focus on that is because, well, they're fun. I mean, quite honestly, it's a really, really entertaining form of mathematics. It's engaging, okay? It's nice to kind of work on a puzzle. It feels good to get your brain working on a puzzle and then to solve it, okay? It's very rewarding. And a lot of these little puzzles that we're going to look at here are really, really rich in examples of logical thinking, and they put you in scenarios where you're using logical analysis here. It's really, really good. So we're just going to do a whole bunch of examples here. And I'm going to start off with just a very, very basic one here. So
3 rows of a pattern are shown below. Find the 5th row of the pattern.
One here. So 3 rows of the pattern are shown below. So row 1, 1 times 8 plus 1 is 9. Row 2, 12 times 8 plus 2 is 98. Row 3, 123 times 8 plus 3 is 987. Now, we're supposed to figure out what the 5th row is, and let's just talk about row 4. What I suspect it is, and I'll just take a look at the pattern here. 1, 1, 2, 1, 2, 3. I suspect this is going to be 1, 2, 3, 4, 8 all the way down, and then every time we added that new number to that value up front here, that factor up front, we added that at the end here. And this, I believe, based on what I'm seeing, should be 9,876. Now, when you go to your calculator, turns out that is true. That is true. 1,234 multiplied by 8 and add 4 is 9,876. So I'm assuming row 5 would be 1, 2, 3, 4, 5 times 8 plus 5 should be equal to 98,765. And if you go to the calculator, actually that will verify that's exactly right.
If the number 8 in the pattern from the first example is replaced with the number 9, as shown below, describe the pattern that could be used to calculate the value of the 7th row.
Okay, so, well, the best way to figure out what's going on here is to actually investigate what the pattern is, what we're seeing here. 1 times 9 plus 1, well, that's easy, that's just 10. Right? 12 times 9, okay, think about that, plus 2, that is going to be 110. Yeah, 12 times 9 is 108, plus 2 is 10. 123, now I had to go to my calculator to do this because I want to do it quickly. 123 times 9 plus 3 is 1,110. Okay here, now based on what I'm seeing here, just take a quick look here at what's going on here. I've got 1, I got 1, 1. 1, 2, I've got 2 1s. 1, 2, 3, I've got 3 1s. I suspect that for my row 7, because that's what it's asking me to do here for row 7, that this would be 1, 2, 3, 4, 5, 6, 7 times 9, and then I would add 7. And I suspect based on what we're seeing here that would be 7 1s. 1, 2, 3, 4, 5, 6, 7 with a 0 at the end there. Okay? And actually it turns out if I go to my calculator, I already kind of did that, and that's exactly what I got here. 1, 2, 3, 4, 5, 6, 7 1s and the 0. Yeah, there we go. Okay.
A student made the following statement. Vote compares to veto as the number 8,750 compares to the number blank.
Okay, so let's just look at this again here. Vote compares to veto. Now, compares to veto. So now, based on the fact that I can see where this is going here, it's now comparing value, numbers here. It's probably not an issue of meaning. Okay, so what we did here is we switched the last letter and the second letter here from vote to get veto. So I suspect that when we take a look at this number, the intention here is that we are swapping those two digits there. So this would become 8057. Whoops, sorry, I can't see that. 8057. I'm just swapping those two just like we saw them do right there. 8057.
What is the missing letter in the following sequence?
Okay, so in this case right here, it requires us to just investigate the sequence here. Now, sometimes these questions about like what's missing in a sequence, that can be very, very complicated. It's also not out there or not unheard of for someone to see a pattern that wasn't the intended pattern. Okay, so don't beat yourself up if you're not getting the number in these cases. If you're not getting the number or the letter or the symbol or whatever that was expected, that happens. Okay, that totally happens. Let's just take a look at this. C, C, D, okay, blank, E, F, G, G, H. Now, I suspect that I'm not supposed to be attributing any kind of meaning to these letters in terms of like representing words and stuff, because you often see sequences like that where the letters themselves are referring to a sequence of words that we're really familiar with. In this case here, what it looks like to me is looks like I'm supposed to focus on this pattern right here because I see it again here. This suggests to me the pattern is C, C, D. I'm guessing E, E, F, G, G, H. So it's the repetition of the one letter followed by a single, repetition of the one letter followed by the single, and so on as we go through here. So I suspect that the missing letter here is supposed to be an E. Now, was that the one intended by the person who wrote this one up? I don't know, but it works. There's a pattern there, and that particular value fills that pattern.
What is the missing letter in this sequence?
Okay, so in this sequence, very similar to the one before it, we're just trying to figure out what that last symbol's supposed to be here. Now, take a look at what we've got here. F, G, E, H, D, I, C. Now, when I look at that, now here, I'm going to give myself a little bit of help here. I'm going to write out A, B, C, D, E, F, G, H, I. Okay, a couple more here. J, K. So on. I'm starting with FG because when I look at this, my eye kind of goes to the fact that it looks to me like I got two different sequences going here. Okay, I've got FG starting here, and then it goes to E, then it goes up to H, then it goes down to D, up to I, down to C, and I believe the next one here should be J. Okay. Because it seems that what we're doing is we're working our way out from the center here, this FG, down one, up one, down one, up one. And so we've really got these two sequences laid together, forming or growing out from FG in the alphabet. And again, is that the one that was intended? I don't know. But that's certainly a pattern that I see right there. And J follows that pattern or continues that pattern.
Hans, Horace, Hilary, and Hannah are students. Hans and Horace speak French, whereas the others speak German. Horace and Hannah speak Italian. Everyone except Hans speaks English. Who are the only ones that speak English and German?
Okay, so to answer this question here, let's maybe write out the names here. So we've got Hans, Horace, Hilary, and Hannah. Okay, so now I'm just going to go underneath here. We're going to build like a little chart here and kind of identify who speaks what here. So now we're told Hans and Horace speak French. Hans and Horace speak French. There you go. The others speak German. Now the others, being Hilary and Hannah, here we go. German, German. Horace and Hannah speak Italian. Horace and Hannah speak Italian. Good. Everyone but Hans speaks English. Okay, so English, English, English. And now the question is, who only speaks English and German? Well, after building that, I can see right there. It's got to be Hilary. Hilary is the one we're looking for.
The goal of this particular puzzle is to fill the circles in a grid with the letters A, B, C, and D so that no letters are repeated in a row, column, or set of connected circles. The 3 entries in the gray circles were given to a student, then the student completed the entries shown in the white circles. Where did the student make the error, and then complete the puzzle correctly?
Okay, so with the rules in mind, here's the way this works here. Let's just follow the logic here. Okay, so we were given the B, the D, and the A right there in those circles, and we're supposed to assume that the student, whoever did this, has put the C, the B, and the C here. And apparently there's a mistake. So let's take a quick look here. Let's just look at the kind of the necessity of this. We know that the rows, the columns, and the connected parts here have to have all 4 of the letters in there. So right now we've got enough to figure out what this is. We've got a C, a B, and an A here. So this would have to be D. Okay. Now, if that's D, sure, I'll make that a bit more clear there. If this has got to be a D, now look, we've got 3 now out of this connected section here. B, A, this has to be C. Okay, so here's where we're running into a problem right now. Okay, now there's 2 C's in this row here. Now, we were told that the student made a mistake. Let's see. Maybe this is the issue here. Let's see if that's the issue. Let's get rid of that. Let's see if the rest of this holds out here, because we've got 3 out of the 4 here. That would make this one here equal, this circle here would have to be A to complete that connected set of circles there. And that would mean that this thing right here, where the student had initially put C, should be B. Let's put the B there. Okay, so that now we've got all 4 letters in that row there. Now, I don't know if that was specifically the mistake or if there was a mistake down here in the CB, but for right now, everything seems to fit. So we're going to keep moving forward until we run into something that doesn't work here. So now notice we've got 3 out of the 4 letters in this particular column. So A, B, C, there's got to be a D up there. What do we got now here? Okay, I've got D, B. Okay, I've got D, B, and so now either an A or a C has got to go in this little set of connected circles here. It's got to, we're missing an A and a C here. So let's take a quick look. Well, okay, I can't put the C here. This has to be the A. And the reason I say this is because I've already got a C in that column. That has to be the A, which means this has to be the C. Now again, I don't know if I'm going to run into a problem here in a bit, but we'll see if this keeps going here. Now I've got 3 in this row. I know that has to be a D. And now if I go up the columns, everything seems to be fairly consistent. So this has to be an A, B, this has to be the C, and this would have to be the B. Now I've got everything filled in. Let's just make sure that I haven't doubled up on anything. And that is actually looking really good. I think that was it. That must have been the mistake that the student had made. And so there you go.
The intention of the following particular 2-player game is to create a line of 4 adjacent squares using the same letter. To play, each player takes turns placing their first initial somewhere on a 6x6 grid. Michael and Gina have started playing the game as shown. Michael determines that he can guarantee a win by placing a letter in what position? His letter M, I should say, in what position?
Okay, so now that we have a sense of what the game, how the game plays here, first of all, take a look at the scenario that we're in. Gina's gone 1, 2, 3, 4, 5, 6 times. Okay, Michael's gone 1, 2, 3, 4, 5 times. So it's Michael's turn right now. And we have, because the question here, Michael determines that he can guarantee a win by placing a letter M in what row and what column here. Now let's take a quick look at what Michael's doing here. Now remember, the goal is to get 4 in a row, and it's his turn right now. So to guarantee a win, okay, to guarantee a win, what we got to do is we got to place a letter somewhere where no matter what Gina does, Michael can always put a letter somewhere to put 4 in a row. Now, look at what he's got right now. He's got kind of 2 in a row, Gina stopped it. He's got 3 in a row, Gina stopped it. He's got this 2 in a row right here, 2 in a row here, but there's more room to move here. Now, this is really where things are going to happen here. What we got to do here is, in order to make this work, I have to place a letter M someplace where I put a third m in two different intersecting rows or columns here. Okay, the reason I say that is because there needs to be the opportunity to put a fourth one on either one of them. So I need to set myself up in two different directions here. And it turns out, if you look at this right here, it has to be this spot right here. If Michael puts an M here, if Gina tries to stop him here, that's okay. He'll put an M here, he'll get 4 in a row. If Gina tries to stop him on her next turn here, that's okay. He'll get 4 in a row this way. Now, the one thing we got to check out, though, is like this doesn't create a situation where Gina wins, does it? If Gina puts one here, well, she doesn't get 4 in a row. But if Gina puts one here, take a look at it. Nah, she gets 3 in a row, but not 4. So that's definitely the place where Michael wants to go. And that is going to be, what is that? That's row 4, column 2. Okay, row 4, column 2.
The pattern of pictures is shown below. The first picture is the original. In each subsequent picture, each shaded square has either stayed in the same place or moved to a square that is horizontally, vertically, or diagonally adjacent to its previous location. The shaded square undergoes the same movement in each subsequent step. Now, which of the following pictures is the next in the pattern?
Okay, so we know the shaded squares are either moving, they're either staying in place, or they're moving a single square horizontally, vertically, or diagonally to an adjacent location here. So here's where we start. Now let's just compare it to here, this particular section right here. Well, we know this one has moved and this one has moved, okay, because this square is now white and so is this one. Now, the only square out of this that is adjacent to this one that's filled in here is this guy. So that has to be the case that this one moved here. Okay, because none of the other adjacent squares are filled in. That's got to be the one here. Additionally, we know that this one has moved to an adjacent square. Okay, now, again, the only ones here that are filled in over here is this guy right here. So it looks like this one's moved this way. Now, you might argue, well, wait a minute, couldn't this one have moved up or this one moved over to fill in that square? Yeah, that's totally true. Yeah, that could have happened. But this one being filled in is the only one that was adjacent to this one that has been filled in. It has to be that corner square here. Additionally, if this one did move up, then we would expect some overlap here and we wouldn't be seeing 4 different squares. It really does look like these two didn't move. And if we go to this next one, those 2 squares are still in that same position. So it looks like these 2 squares are staying still. This one appears to move up here. Now let's just see if that's consistent. This one seems to have moved up. This one seems to be moving down along this diagonal, goes to here. If that's true, then it should be, and there it is in this final spot here. So I suspect the next place that's going to happen is that, and I'll write it like this. This one's going to move up to here. I suspect that one will stay, that one will stay, and this one is going to move down to this place right here if this pattern continues. So this little line of 3 and in the corner. So which one is it going to be? Oh, there it is, right there. Hey, that's the one I was predicting. This little line of 3 plus that little corner there. Good.
In a Kakuro puzzle, each partial row or column can have the digits 1 to 5 inclusive, but no digit can repeat. The sum of each row or partial row is indicated by the number to the left of the row. Similarly, the sum of each column or partial column is indicated by the number above the column. Part of the following puzzle has been completed. When the puzzle is completed, the values of A, B, C, and D are respectively what?
Okay, so the rules have been explained here. We need to make sure that these things add up to the numbers up top there. And we're only supposed to use the digits 1 through 5 inclusive, and we can't repeat them, okay, in any row or partial row or column or whatever. Okay. So actually, it turns out it's a little bit easier to read these numbers on the screen than it is looking at this piece of paper here. Now we got to start with kind of the low-lying fruit here. This sum right here needs to be 8. Well, 1 and 3 here, this has got to be 4. Okay, if that's going to keep going here. This sum here, I think we get our sum with the value on the left here, this has got to be 7. So that means B here has to be equal to 1. in order to make that work. B has got to be equal to 1. Okay, so we've got that much right there. What else can we do here? Well, we know this sum right here. We go across here. This is 3. This sum here needs to be equal to 5. That makes this equal to 2. Okay. And if these two are going to add up to 5 up top here, then this C here has to be equal to 3. Okay, well that's easy enough. What do we got here? 1 and 2 is equal to 3. That's easy. 2 and 1 here. This has to be equal to 3 as well because of the 3 down there. Okay, now, what else have we got here? Well, we got 15. Okay, this sum right here has to be 15. What have I got? I've got 3, 2, 1. Okay, I got 6. So these two here have to add up to be 9. Now, I've got 4 and 5 to work with. So now, it's a bit of guesswork here. I'm trying to see if there's any other little shortcuts I can take. Well, okay, I can work my way around that a little bit here. I can start over here and work my way into this maybe, because this is 3, this has to be 1 if these two are going to add up to 4. If this is going to add up to 6, then A here has to be equal to 5. Okay, so now I've got 5 in this row right here. Okay, I'm missing 2 and 4, but I wanted these two to add up to 9. Okay, I suspect this has to be my 4 here. Okay, because I still need the 2 in this row here, but I didn't want to put the 2 here because then I would have an additional 2 here. So that has to be the 2, this has to be the 4. If this is 4, this one up here has to be the 5 so that these add up to 9. This all adds up to 15. Okay, so I hope that made sense here. I came over here to just fill in this little number here, and that gave me what this had to be here. This has to be 5. And that throws some limitations on these values. This had to be a 4 and a 2 or 2 and a 4, but it couldn't be 2 here. Had to be 2 here. Kind of eliminates my choices there. Now, I'm going to work my way up here. What have we got here? This has to be 1, 2, 3. Okay, this has to all add up to 15. So I'm looking for the 4 and the 5 here. Except the 5 is already here, so D can't be 5. This has to be equal to 4, which means this is 5. This little row right here is supposed to add up to 6. If this is 5, this must be 1. If this is 1, this little column here has to add up to 3, so this has to be 2. And then that makes whoops, sorry, I said 2 and I wrote 3. That is so odd. But that has to be 2, which makes perfect sense because now this lineup right here has got the 1, 2, 3, 4, 5. Perfect. Just exactly the way it's supposed to be. And so now I'm supposed to identify over here what the numbers, the values are for A, B, C, D. Okay, well, where was A? A is 5, B was 1. So 5, 1, what do we got here? 5, 1, 3, 4. 5, 1, 3, 4. Those were the numbers we were looking for.
Magic squares are arrangements of numbers in a square grid where the numbers in each row and column and each diagonal add up to the same number, as in the following example. The following magic square is partially completed. The values of A, B, C, and D respectively are what?
All right, so we're told this is a magic square. If that's the case, then we should be able to figure out what the total is by just looking at this particular column right here. And it turns out the sum of that column is 30, okay, which gives us a bit to work with. Because now anytime we got a row or a column that's got at least 2 numbers in it, we know what the third one is. So for example right here, if this is 15 and this is 11, okay, well 15 plus 11, what is that? That's going to be 26. So D here has to be 4. Think of it like this now, 17 and 3 is 20. That means C has to be 10. Okay, if C is 10, 10 and 15 is 25. That means B here has to be 5. And now that we got to see if we are on the right track here, there are 2 different ways we could come up with the A value. Now let's just take a quick look at this. 5 and 16 is 21. That would mean A would have to be equal to 9. Now let's just see if that works here. 9 and 4, sorry, let's do it like this way. 9 and 17 is 26 and 4 is 30. So because I got some consistency in both directions here, I know that I'm right here. So to fill in the values here of A, B, C, and D, A we said was 9, B we found out was 5, C was 10, and D was 4.
Using the numbers 1 through 36, fill in each square so that the numbers follow a linear pattern, but you cannot go diagonally.
All right, well, I'll be honest with you guys. When I first read this question, it took me a while to figure out what it was asking. I was not clear as to what we were supposed to do. But the intention is, what we're going to do is we're going to fill up all of these squares with the numbers 1 through 36, and we're going to have basically just like a constant little train of numbers here, like 1, 2, 3, 4, 5. Like those numbers are all going to be connected to each other orthogonally. Okay, so for example, just to give you an idea here, look at where 1 is. We're going to start with 1, we're going to end with 36. Now, I can only go orthogonal, meaning I can only go this way to put new numbers in. So either I'm going to put a 2 here or a 2 here. Now, but I want to get to 4, and if I put a 2 here, I can't get to 4. So 2's got to go here, and then 3's got to go there, and now I can connect up with the 4 that they've given me. Which means I only got one place to go. I can only put 5 here, and then I got 5, 6, 7. And that's what they're getting at here. We're just going to follow this little train of numbers, and we're going to kind of snake our way through this whole thing and get to here eventually. So anyway, let's just keep going here. So we got to here, 7. So this has got to be 8. There's really no other options here. But it could be 9 or it could be 9 here. Now if I put 9 here against the 12, I'm stuck in here. I'd have to go 9, 10, 11, and I can't connect to 12. So this has got to be the 9, 10, 11. 12, 13, this can only be 14, 15, this can only be 16 because there's only one place to go. But this could be 17 or 17. Now if I put 17 here, I would have to go 18, 19, and then that doesn't connect to the 20. So this has to be the 17, 18, 19, 20, 21, 22. Okay, now 23 can go either one of these places. Okay, and then I go to 24. And then I'm kind of stuck here because I don't have the I got to get to the 27, right? Now if I put 23 here, go 24 or 25, I'm not going to connect to the 27. Like I can't. But if I put 23 here, 24, 25, whoops, sorry. I was going to put 52 there, I don't know why. 25, okay, here, 26, 20, there we go. Okay, that was a little weird there, a little snake up and then down and around. 27, this has to be 28, 29, this has to be 30, 31, this one here has to be the 32, 33, 34, 35, and then 36, and there we go. So we've put all the numbers out, and we snake it all the way around up to 36 in that top corner there. Good.
You can use only the numbers 1 through 4 in this puzzle. Each number must be used exactly once in each row and column. The numbers in each outlined group must arithmetically equal its given formula.
Okay, well, there's a bit going on here. Notice we're not given really much introduction to this one. I know that these two have to add up to 7. These two got to multiply to 6. They got to multiply to get 4. These, their product is 8. The sum here has got to be 6. The quotient here is 3. The quotient here is 2. Okay. Oh, boy. Well, let's just start at the top here. To get 6, what do we got here? We got 3 times 2, right? 3 times 2. There's 6. If I'm going to get 7 here, okay, 7 would be 3 plus 4. In fact, that's the only 2 digits I can get out of 1, 2, 3, 4 that'll do that. I can't put a 3 here because there's a 3 here, so this would have to be 3, 4. Oh, sorry, I don't know. I don't know why I just did that. I just said you can't put a 3 there. So that would have to be 4, 3. Okay. Now let's see, coming down here. Well, that would leave this with 1, which would make this 4. Okay. Down here. Oh, okay. We're going to run into a problem right here because this is supposed to be a 3. When you divide these two out, I'm supposed to get a 3. Okay. So there's got to be a 3 in one of these two spots here. But I run into the problem because I can only have the numbers 1 through 4 in each row and column. So there has to be a 3 down here, but I've got 3s here. Well, okay, no matter what I do, there has to be a 3 here. There has to be a 3 in one of those two. So I must have made the mistake right off the bat. That couldn't have been 3 and 2. That would have to be 2 and 3. Okay, so now this means that this would be the 3 here, and this would have to be the 1. Okay, now let's hope that I don't run into any kind of other issues like that. So this would put a 2 here. To get a product of 8, I need a 4 and a 1 here, but I can't put the 4 here because there's a 4 already there. This has to be 1, and then I have no other choice. It's got to be 4. These ones are going to add up to 6 there, which means that's got to be 1, 2, 3. If there's 3 numbers here, to finish this row, I got to put a 2 there. So it's got to be 1 and a 3. Now the 3 is in this column already, and the 1 is here. So essentially, I just got to flip those 1 and 3. Okay, and then down here, the quotient of these two has got to be equal to 2. But this is like 3, 2, 1. So this this has to be 2. Oh, and this would have to be 4. In my head, I'm sorry, the reason I paused there for a second is because when I looked at that, I thought it has to have a quotient of 2. Immediately I thought 2 and 1, but obviously 4 and 2 also works to make that work. So yeah, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and go this way, I get the same thing. There we go, all filled in.
4 children have different birth months, but were all born in the same year. Find out who was born in each month.
Okay, well, to fill this in, let's take a quick look here at the rules. Cal was born before Deb. Okay, well, that really doesn't give me much information. I mean, I know it's either going to be like Cal Deb, Cal Deb, Cal Deb, or Cal Deb. Like there's a few different ways that could happen. So, yeah, we'll come back to this one. Deb was born 2 months before, 2 months after Bob. Oh, okay. So, like if Cal was born in January, then Deb is born in March. So if Cal is born in February, Deb is born in April. So what that tells me is this has got to be, sorry, did I say Cal? I meant Bob. Sorry, Bob. Bob's got to go in one of these two, and Deb's got to go in one of these two. Okay. Bob was born after Amy, but before Cal. Okay. Well, that is now saying something, because if Bob was born after Amy, then, and these are the only 2 spots Bob can go, Bob has to be in February and Amy has to be in January, right? And if Deb is 2 months after Bob, that means Deb has to be out here in April. And that only leaves us 1 more spot. Cal's got to go right there. So there you go. That's how you'd work that one through. The real kind of breakthrough in this question comes when you think of those two points 2 and 3 together.
Sudoku is a puzzle where the objective is to fill a 9x9 grid with digits so that each column, each row, and each of the subgrids contain all of the digits 1 through 9.
Okay. I was wondering if we were going to get to do one of these things. This is an extremely popular form of puzzle here. It's a lot of fun here now. So you've just heard the description of it. So we're looking to get just the numbers 1 through 9 in all of the rows, all of the columns, and all of the little squares here. So now we've done questions in this lesson here similar to this. But anyway, here's the Sudoku. Okay, so there's a lot going on here that I can work with here. So I'm going to take a quick look at the 9s, just because immediately I see a bunch of 9s here. Like for example, I see a 9 in this row. Column. I see a 9 in this column. There has to be a 9 somewhere in this column, and it has to be in this box, right? Because there's already 1 9 here. There's already a 9 here. It's got to be somewhere in here. There's a 9 in this row already, so that's like killing this, and these 2 9s kill that. Well, it's got to be right here. The remaining 9 has to be right there. Okay. So there's 9s there. I've got a 9 here. Okay, there's no 9 right here, and there's no 9 right here. Now, in terms of intersecting here, it's this row intersects, this column intersects. Now, that still leaves me with a couple of options here. Let's see if there's any other clues I can get. Okay, down here at the bottom, there's a 9 in this row. Okay, there's a 9 over here in this row, but I'm missing a 9 in the middle. Okay, now with those 2 gone, the 9s can gotta go either here or here, but there's a 9 at the top of this column that kills this one. So the 9 has to go here. Now, that being said, I can go back up to the middle because now I know there can't be a 9 here. There can't be a 9 here in the middle. That leaves these two spaces, but there can't be a 9 there because the 9 has got to go there, right? Because it's going to kill it right there. Good. Is there any place else? Well, yeah, let's keep going into this right here. Okay, still working with the 9s here. I can't have a 9 up here at the top. I can't have a 9 down here at the bottom in this little grid here. So that leaves the two middle squares, but because of this 9 right here, I can't have a 9 there. The 9 in this box has to go right there. Okay? And then up at the top, look at this. This 9 here kills this one, but this one was also going to be stopped because of that 9 right there. So this one here in the middle is dead, and then so is this one right here because of that 9. So the 9 up here in this box has got to go right there. Good. Okay. Let's keep going here. Let's see what else we saw. What else did I catch a glimpse of here? The 3s. Well, maybe I've got a thing for 3s and 9s here, but there's a 3 here and there's a 3 here. Notice there's no 3 in the middle, so that reduces it down to the 3 that goes here has got to go into one of these two. There is a 3 down here though, so the 3 in this box has to go right there. Okay. What else have we got here? There's 3s there. There's the 3 there. Where I'm also okay. I'm missing a 3 here. Let's see if I have enough information to help myself out here. There's a 3 right here coming across. There's a 3 right there. So that means the 3 in this box has got to go in one of these two. But there's a 3 in the top of this column that kills this one. So the 3 in this box has to go there. Okay, there are no 3s in this bottom one. Okay, this is a good one. So this 3 here kills it here. This one, kills it there. The only open space that a 3 could go in is this guy right there. All right, what else have we got here? This one. This box here doesn't have any 3s in it. There's a 3 in this row, so it kills that. Actually, and then this one is already full, so the 3 can only go here or here. But there's a 3 right here. So then the 3 in this box has got to go there. Okay. Now, at this point in time, I'm going to switch gears a little bit. I want to show you another way of thinking because a situation has just kind of popped up here. Look at this row right here. I've got all but 2 of the numbers here. Now let's just see what's missing here. I've got 1, 2, 3, 4. Okay, the 5 is missing. Okay. 6 is missing, then I got 7, 8, 9. So if the 5 and the 6 are missing here, so I've got 2 places for the 5 and the 6 to go. It can either be 5, 6 or 6, 5. Those are the only 2. But notice that there's already a 5 in this particular square here. So in this row, this has to be a 6, which would mean this has to be the 5. And so now we finish that line. I can do a similar sort of thing with a square. Okay, so I'm going to just erase this so that I can, if I need outside stuff, I can put it there. Notice in this square right here, I've got everything but 2. Okay, 1, 2, 3, 4. So it's the 2 and the 4 that are missing here. Now, look outside for clues. In this particular column, there's already a 2. So this square here can't be the 2. This would have to be the 4, which would make this the 2. And now I filled in that square. Okay? Now, what else can we look at here? I don't see anything. Well, here, this bottom line has also got all but 2 of their numbers in there. So what am I missing down here in this row? Well, I'm missing a 1. I don't even have a starting place. So 2, 3, 4, 5, 6, 7. I'm missing the 1 and the 7. And again, immediately, as soon as I identify that, like I notice, hey, well, but there's a 7 in this particular square, which means this number here can't be the 7. This one would have to be the 1, which would mean this would have to be the 7. And as soon as I've done that, I've given myself an opportunity right here because this one has got all but 2 in them. In this square right here, now I'm missing the 1, 2, 3, 4, 5, and I'm missing the 6. In this column right here, I've already got the 1. So this number here can't be a 1. This has got to be a 1, which means this is my 6. Just erase my little help out there. Good. All right, everything's coming along here. Now, okay, and then as soon as I filled that in, I can see right now this column right here has got all but the two numbers in it. Let's just see what's missing. 1, okay, there's a 2 missing, 3, 4, 5, and the 6 is missing. Okay, so it could be a 2 or a 6 here, or a 2 or a 6 here. Now let's just take a quick look. Okay, I'm not getting any clues there as to what's going to go on there. So, oh, sorry, you can't see my little clue there. Okay, this is a neat thing to. Oh, shoot, no, I do see the clue. I was going to say there's no clue. We have to move on, but there is a clue here. There is a 6 in this box. Okay, there is a 6 right here in this box, which means this one here has got to be the 2, which puts this up here as the 6. I didn't quite see that. There's no big deal in moving on and trying something else here, but it worked out, okay? It filled that in here. Now, do I get any other boxes here where I've only got a couple that are missing? Not at this point here, so let's take a quick look at something else here. What's missing in this box right here? Well, I'm missing an 8, okay? And I don't know what my propensity is. This is just me, like thinking the numbers through backwards. Like you saw me focus on 9 immediately and working backwards through 8. There's really no rhyme or reason to that. I'm just kind of choosing some place to start. But in this case, looking at 8, I need to put an 8 somewhere in here. Now I can't put an 8 here because of this 8. And I can't put an 8 in either one of those two. Actually, that worked out really nicely because that only leaves me with one opening. An 8 has got to go there. There's no 8s over here. Okay, there's an 8 in this middle row, and then there's an 8 in this final row, which basically pushes me. There's got to be an 8 right there. Okay, there's no 8 here either. So let's see what we've got already. We know that there's an 8 down here, so there's no 8 in this row. There's also no 8 in this column, and that only leaves one opening here for the 8 right there. And then in this last box here, I've got an 8 here, I've got an 8 there. Yeah, the 8's got to go in the middle. And there we go. Now, fortunately for us, that left me open with a line here that's got only the 2 unknowns. So what am I missing? 1, missing a 2, 3, 4, missing a 2 and a 5. 6, 7, 8, 9. Yeah. So 2 and a 5 here I'm missing. Now, notice that this column here already has a 2 in it. So this has got to be a 5, and this has got to be where the 2 is. Okay? And then that gives us this line right here, this column, that has got all but the 2 missing. And what's missing there? The 1 is missing. 2, 3, 4, 5, 6. Then the 7 is missing. Okay, so do I have any clues? And I really don't, because my unknown here, my unknowns are both in the same line there. All I know is that this has got to be a 1 and a 7 somewhere here. So I need to kind of go looking for some other clues. Okay. In fact, I tell you what. Let's start looking at the 1s. Let's start looking at the 1s. We'll go to the other end of the line there. There's no 1s up here, but there's a 1 in this column. Sorry, this row. There's a 1 in this row. Now in this particular box here, that only leaves me with one opening. That could be a 1, so it's got to go there. In this particular box right here, there are no 1s, but there's a 1 now in this column, and there's a 1 down here in this column, which only leaves this possibly as a solution here for that. Oh, okay, actually, that helps us out over here. I'm sorry, I know I'm jumping ahead here. I was going to kind of snake my way through, but actually that helps us right here, because I had known that these had to be either a 1 and a 7. If the 1 is now here, that means this has to be 1 and this has to be 7. So they don't overlap. So I don't need that anymore. Good. Now this is all coming together quite nicely, quite smoothly here. In this particular box, okay, in this box, I've got 2 that are missing. So let's take a quick look at what's missing here. 1, 2, 3, 4, okay, 5 is missing, and the 6 is missing. But in this column, there's a 5, so this has to be my 5, and that has to be my 6, and that went together quite smoothly. And now, I don't know if you see it here, but look at this line at the back here. There's only one missing value here. 1, 2, 3, 4, 5, 6, 7, 8, 9. You love it when that happens, when there's only the one that's unknown here. And that leaves us with one unknown in this box. 1, 2, 3, 4, 5, 6, there's my 7. And then keep looking here. That leaves us with only one unknown in this line. 2, 3, 4, 5, 6, 7, 8, 9. Which leaves us with only one unknown in this one. 1, 2, 3, 4. This has got to be the 5. That leaves us with only one unknown in this box. 1, 2, 3. There's got to be a 4 here. That leaves us with one unknown here. 1, 2, 3, 4, 5, 6, 7. This is my 8. Okay, and that's the end of that fun. Okay, now I don't have any columns or rows that have only one unknown, so I still got to do a little bit of work now. Let's take a quick look. Let's look at this one. It's always nice when you got a row or a column where the unknowns straddle two boxes here. Let's take a look at this one. I'm missing a 1 here. So 1, 2, 3. I'm missing a 1 and a 4. So 1 and a 4. Well, okay, this can't be the 1 because there's a 1 right here. This has to be the 4, which makes this the 1. Probably would have found that earlier if I'd kept looking for the 1s, but I got sidetracked by what was going on over here, and man, that really helped me find a lot of this puzzle. So that's got to be my 1 and my 4 there. Now that leaves me with a column here that only has one empty spot. So 1, 2, 3, 4. 4 is missing. 5, 6, 7, 8. Yep, 9. That gives me a row here that's only got one unknown. 1, 2, 3, 4, 5. This has got to be the 6, 7, 8, 9. This particular column here only has one unknown. 1, 2, 3, 4. This is the 5. 6, 7, 8, 9. This square now only has one unknown. 1, 2, 3, 4, 5, 6. This is the 7. And now, granted, this box has two unknowns, but these two columns here have only got one unknown. So let's do this one here. 1, 2, 3. Oh wow, look at that. 1, 2, 3, 4, 5, 6. There's my 7. 1, and there's the 2, the missing 2. And there we go. Okay, now what I've just done here with you guys is just one way of approaching the Sudoku puzzles here, where you look at the overlapping here and whatnot. This puzzle here, where you look at the overlap, you look at what's missing, and you're just kind of you're thinking this thing through logically, because in many cases you don't really have any choice, really. What goes in those squares has to be a certain value. When these puzzles get a little bit more difficult, where the difficulty lies is you get situations here where you really don't have any indication, and you actually have to guess. Okay, you have to make a guess. You're at that point you're not guessing some number between 1 and 9. Typically, you'll have it worked down to like 2 or 3 possibilities, but you have to make a guess, and that's what makes those things so diabolically hard.
Place the numbers 2, 2, 2, 3, 3, 3, 4, 4, and 4 in a 3 by 3 grid like the following, so that when any line of 3 numbers is added in any direction, including diagonally, the sum is always 9.
Okay, so here we go. So this is in a little bit like a Sudoku here, because really what we're doing here, well, okay, the way to think about this is I need the sums along the columns and the rows here to add up to 9. But look at the numbers I've given, 2, 3, 4. Okay, well, if you add 2, 3, 4, you're going to get 9. So essentially what you're saying here is I need to have the numbers 2, 3, 4 in every row and column and so on, which is kind of like a Sudoku here. Now, to start off with here, and you can see I've already worked on this a little bit here to see if I could figure out what's going on here. And it turns out there's kind of an interesting little twist in this problem here, and I'll take you through it. But to start off with here, because we're given really no indication of where to go with this, I'm just going to put 2, 3, 4 here. I mean, why not? I have to start anywhere. And then I'm just going to kind of guess at what the next row would be, or the next column. And I'll just offset that number, maybe make this 4, 2, 3. So now I've got, this would have to be the 3, this would have to be 4, and this would have to be 2. Now does that work? Okay, well, that's going to be 9, 9, 9. This will be 9, 9. Well, this is looking actually really good. 4, 2, 3 is 9. 2, Oh, here we go. 2, 2, 2. Okay, well, 2, 2, 2 isn't 9. It's going to be 8. It's close, but it's not. It's not 9 there. Okay. Now, I suspect that's going to happen regardless of what I do, that I'm going to get this little issue here where I'm going to get this repetition. Because think about it. If I erase that, if I put 4 here, okay, well, then I'm going to get 4, 4, and probably 4, and that's not going to be 9 either. Now, I could do this, though. What if we put a 3 there? Okay. Now, the problem I run into is that then I've got 2 3s in a row here. But if I put another 3 over there, that adds up to 9. Now, that tells me that, you know what? Although I can't have all 3 3s in one row or column, I could have all 3 3s along that diagonal where that 2 was. Okay? And so let's let 3 sort of take the place of 2, because that does add up to 9. So let's maybe make this 2, 4, and then make that 4, 3, 2, and then this would have to be 2, 4, 3. Now, have I gotten around that problem here? That's going to be 9, that's going to be 9, that's going to be 9, 9, 9, 9, 9, because I designed it like that, and then there it is. So everything there adds up to 9, just like it's supposed to.